This is the video for 10-2, and we are talking about radical expressions. A radical expression is any expression containing a radical symbol. And remember, if there's no index written, the index is 2. Rationalizing the denominator is a process that we are going to learn about, and it is a way to eliminate any radical expression that's in the denominator. Now, before we begin, let's go back to elementary school when you first started learning about square roots. The square root of 4 is 2. But why? Let's think about this. What is 4? Once I break 4 up into its prime factors, 4 is the same thing as 2 times 2. So the square root of 4 is 2, because here is the rule in the lesson today. Every time you have a group of 2, 1 gets out. So that's why the square root of 4 is 2. I want you to think of these radical symbols as jail. And these numbers want to get out of jail, but they have to be in a group of 2 in order to do so. So the rule is, every time there's a group of 2, 1 gets out. Okay, so now that we went over that, I want you to find the square root of 160. So how do you do this? Well, first of all, always take your calculator and determine, is this a perfect square? Because if it is a perfect square, you don't have to go through this process. But if you take your calculator and try to find the square root of 160, you will find that this is not a perfect square, so you have to go through this process. So this is what you do. You break down 160 into its prime factors. Most of you probably learned how to do this by using a factor tree, and if you need any reminding on how to do this process, email me. But I'm assuming that you have learned how to break down a number into its prime factors. Again, I think most of you were probably taught how to do that in elementary school using a factor tree, and that's the method that I use. But once I break down 160 into its prime factors, this is what I get. 2 times 2 times 2 times 2 times 2 times 5. And so now remember the rule. Every time there's a group of 2, 1 gets out. Every time there's a group of 2, 1 gets out. So what got out of jail in this situation? 4. Because 2 2's got out, and 2 times 2 is 4. And then what was left inside of jail? 2 times 5, which is 10. So this is the final answer. So pause the video to make sure that you understand what I did. And then when you're ready, let's look at the next example. The square root of 2,401. Well, I always say, always start by taking your calculator and trying to find the square root of 2,401, because it may be a perfect square and then you don't have to go through this process. And here in this situation, it is. It is a perfect square. You can use your calculator, and the square root of 2,401 is 49. Okay, now go ahead and hit pause and work out this on your own problem and find the square root of 72. And here's the answer. Once I break up 72 into its prime factors, this is what I get. Every time there's a group of 2, 1 gets out. And so then what got out of jail was 2 times 3, which is 6. And what was left inside the jail? 2. So my final answer is 6 times the square root of 2. Example number 2, you're going to do the same thing, except now we're going to include variables. So I have the square root of 54n to the 7th. So what do? I break up 54 into its prime factors, and I also break up n to the 7th into its prime factors. Now what's the rule? Every time there's a group of 2, 1 gets out. So what got out is a 3. And then how many n's got out? 3. What was left inside the jail? 2 times 3, which is 6, and then 1 variable n. And so this is my final answer. So go ahead and hit pause and make sure that you understand what I did, and then when you're ready, do this on your own problem. Now, be careful. Because I have this negative m already outside the prison walls, anything that escapes this radical symbol needs to be multiplied with what's already out there. And here's the answer. I broke up 80m to the 9th into its prime factors, and then every time there was a group of 2, 1 got out. So 2 2's got out, and 1, 2, 3, 4 variables got out. But now I had to multiply that with what was already outside the prison walls. I have to multiply them all together, and then this is my final answer. 5m is left inside the jail. Once everything that could escape got out, 5m is left inside the radical symbol. Now, you will start to develop some mental shortcuts in this process, but I'm not going to force that because over the years I've found everyone develops their own mental shortcuts at their own pace. So until you do start developing some mental shortcuts, just go through the process of writing all of this out. Example number 3. Now it may seem like I'm going through this fairly quickly, but I'm expecting you to pause the video along the way and work these out. So this video should take you a lot longer than just 15 minutes to go through. Okay, now we're going to multiply 2 radical expressions together. The process here is the exact same, except now we're going to be multiplying 2 radical expressions together first before you reduce it, before you simplify it. So how do I do this? Well, the first thing I do is multiply together what's on the outside. So 2 times 3 is 6. Now I multiply what's inside the radicals together. I have 7t times 14t squared. 7 times t is 98. T to the first power times t squared is t to the third. And then what did I do here? I did the exact same thing I've been doing. I break it down into its prime factors. Every time there's a group of 2, it can escape. And then don't forget to multiply it with what's already on the outside. So remember, when multiplying 2 radical expressions, you multiply what's on the outside first, then you multiply what's inside the radical expressions together, and then you can go through the process of simplifying. Break it down into its prime factors. Every time there's a group of 2, 1 can get out of the radical symbol, and then don't forget to multiply it with what's already on the outside. Now work out these 3 on your own problems. And here are the answers. Pause the video and compare your work against mine. If you have any questions, please email me. Now look at this last one, and I said you're going to start developing some mental shortcuts. Here, The square root of 100 is 10, so I know a 10 is going to escape from the jail. Here I have 6 variables. The square root of x to the 6 is x to the third, because I have 3 groups of 2 variables inside the prison walls. So x to the third, or 3 variables, can get out. So some of you may be able to do that without writing out all of the prime factors, and if you can, great. But again, if you still right now need to write everything out, please do so. Example number 4. All I'm doing is showing you how mathematically this and this are identical. The square root of 64 over 49 is mathematically equivalent to the square root of 64 over the square root of 49, which is 8 over 7. This fraction within the radical is mathematically identical to this fraction with radicals. And so here we have the same thing. The square root of 8x to the third over 50x is the same thing as saying the square root of 8x to the third over the square root of 50x. And then what do? I break up the top into its prime factors, I break up the bottom into its prime factors, and then I just take it one at a time. I look at the numerator, and then I look at the denominator. Every time there's a group of 2, 1 can get out. Every time there's a group of 2, 1 can get out. And then what happens here? Those cancel each other out, and then this is what I'm left with. Now go ahead and practice and do these 3 on your own problems. And here are the answers. Again, pause the video and compare your answers against mine, and if you have any questions about what I did or how I got my answer, please email me. Watch, right here you have to reduce. You have 6 over 2. Be careful, 6 over 2 is the same thing as 3. And finally, example number 5. We are going to rationalize the denominator. That means you have to remove the radical symbol from the denominator. You cannot have a radical symbol in the denominator. So how do I do this? Well, I multiply both the top and bottom by the bottom, because watch what happens when I do so. The square root of 3 times the square root of 7 is the square root of 21. The square root of 7 times the square root of 7 is 7. Because look, the square root of 7 times the square root of 7 is the square root of 49, which is 7. So that's why this always works. When you multiply the bottom by itself, that will remove the radical from the bottom, and that's the goal. That's what we're trying to do. The next example is the same thing. I want to remove the radical from the bottom. So what am I going to do? I'm going to multiply both the top and the bottom by the bottom. When I multiply the top by the bottom, what do I get? The square root of 7 times the square root of 8n is the square root of 56n. And then the square root of 8n times the square root of 8n is the square root of 64n squared, which is 8n. If you multiply the bottom by itself, it will remove the radical. Make sure that you understand why that works. And now I just do exactly what I've been doing. I simplify. I break it down into its prime factors. Every time there's a group of 2, 1 can escape, and then this is what I have left. Then I reduce. 2 over 8 is the same thing as saying 1 over 4. Now be careful. You cannot reduce these ends. You can't cancel them out, because I cannot cross these out. You can't take what's inside a radical and say that it's equivalent to what's outside of a radical. The square root of n and n are not mathematically identical. So we cannot cancel these n's out. One's inside a radical and one's not. So this is going to be my final answer. Now go ahead and hit pause and work out these three on your own problems. And here are the final answers. If you have any questions, please email me and I can work anything out for you in a private video link and I can mail it to you.